All right, friends, here we go. We are talking about graphing polynomials today. All right, so recall the rational roots theorem. That's where we make our list of all the possible rational roots. Okay, next we have the fundamental theorem of algebra, which says every polynomial function of degree n is greater than or equal to 1 has at least one root, where a root may be a complex number. In other words, there are roots to solve for whether they are real or imaginary. Okay, so fun fact. If the polynomial p of x is divided by x minus a, then the remainder is p of a. What that means essentially is that you can use synthetic division to go ahead and evaluate functions. Okay, so for example, if we divide this polynomial in a using synthetic and then try and evaluate when x equals 3. So here's what we get when we do the division, right? And of course we get our quotient with our remainder of 7. But then also, if we take the function, same function, and if we were to sub in a 3, we would get 7. Okay, and so you can see that you can actually, that remainder that you get when you do division, that's also what you'll get if you were to evaluate that function at that particular value. Okay, so next, end behavior. End behavior is determined by the lead term in any polynomial. Okay, so let me move myself because I'm in the way of this chart here. Okay, so if you take a look at this chart, you can see what happens if the lead coefficient is positive, but the degree of the lead term is odd. Okay, you kind of have that down-up situation. If it's even, it goes up in both directions. And then if you have a negative lead coefficient, if you have also an odd degree, it goes kind of like down, up to down rather. And then if it's a negative lead coefficient, but the term is overall even, then that goes down in both directions at the ends. Whoops. Okay, so let me move myself again. Okay, so some suggested steps to graphing are these. Okay, so if you want just to kind of follow the steps, maybe go ahead and pause it. But these are the general steps you kind of want to try taking. Okay, so for example, if we wanted to give a rough sketch of this graph, we'd first use rational roots theorem to come up with our possible list. Then we'd start testing our list and we'd be like, dang, that one didn't work. And so then we try maybe another one and then that one works, yes. So then we can start factoring and then we can solve and we can find the roots. So now we got the roots. Now let's go ahead and find the y-intercept. That's the place where the x is 0. In other words, it's going to be wherever your constant, or whatever the constant term is, 0, comma, whatever the constant term is. And you can start to piece together the graph, put the zeros on the x-axis, put the y-intercept on the y-axis. Okay, maybe find a couple other points quickly using your synthetic substitution. Okay, determine the end behavior based on the lead term. And voila, you can put your graph together. Okay, so let's try this wee problem. Go ahead and pause it, give it a shot. Okay, so here's going to be our possible rational roots. We're going to start testing. Turns out the first one that I tested actually worked. And then we start factoring and then go ahead and solve. Set f of x equal to 0. Go ahead and solve for the roots. Find the y-intercept, 0, negative 6. Determine the end behavior, and voila, you can kind of start to piece a graph together. Okay, why don't you pause it and give this one a try. Okay, and if you've done it correctly, you should wind up with a graph that looks something like this. All right, my friends, good luck and get to the practice.